all. Let me share my screen first. Okay. So today we're going to talk about conical lock spiral antenna simulation using HFSS Antenna Design Toolkit. This is a very simple simulation that I'll show you later on. So before we go to the simulation, I would like to introduce some of the Ansys product. So if you can see in the slides, these are all the product that we support, and mainly structure, fluid, and electronics. So for today, we're going to talk using HFSS under electronics. So in Ansys Electronics, we have HFSS, Maxwell, SI Wave, iSpec, AutoCAD, EMA 3D cable, 3D extractor, EMA 3D charge, and NOHITS filter solution. And if you want to know more about this product, you can search through this link here, ansys.com/product/electronics. And today we're going to talk more about Ansys HFSS. So what is HFSS? HFSS stands for High Frequency Structure Simulator. It is a general purpose full wave 2D and 3D electromagnetic design simulation tool for high frequency application. So what are the high frequency application? We cover all of this: antennas, microchips, filters, integrated circuits, printed circuit boards, radio frequency component, and microwave component. So for today, we are mainly going to talk about antennas. What are antennas? Antennas is for send and receive electromagnetic signals. So these are the picture. This horn antenna. This is one of the example of an antenna. The horn antenna. But today we are going to simulate a spiral, conical spiral antenna. And what are criteria for designing an antenna? First is the bandwidth, the range of frequency for a particular signal, polarization, the direction of the electric field radiated by the antenna, directivity, the degree that the radiation is concentrated in a single direction, the physical space, the size of the area where the antenna must fit, the gain, how much power is transmitted in the direction of peak radiation, and lastly, the efficiency, the ratio of the antenna radiated power to its delivered power. So by using HFSS Antenna Design Toolkit, we can automate the geometry creation, the solution setup, and the post-processing report for more than 60 antenna elements. These are some of the main antenna design, antenna type: the bow tie, conical, spiral, custom, dipole, helix, horn, lock, radix, miscellaneous, monopole, PIFA, patch antenna, planar spiral, reflector, slot antenna, Vivaldi antenna, waveguide, and Yagi Uda. So this tool allows antenna designer to efficiently analyze common antenna type using HFSS and assist the user in learning to use HFSS antenna design. So for today, we are going to see how to design a conical spiral antenna. So this is inside Antenna Design Toolkit. So the specification here, these are the parameters. On the left side is the parameters, the low frequency. We need to put the low frequency, the high frequency, the outer boundary, and then the dimension is based on the graphic here. The inner radius are not here. You can see the number of turns, the offset angle here, the expansion coefficient, and the cone height. The cone height here. So basically, if you're using the design toolkit, we just plug in all the parameter, and after that, they'll create us a full design for this antenna. I'll show you during the demo. So for the demo, firstly, for the simulation setup, we assign all the parameter in the antenna design toolkit. We analyze and start the simulation. And after the simulation, you can observe the result for the low and high frequency of the antenna. So if you can see, these are the example of the result. It can be seen. The gain right-hand side circular polarization in 3D. The left-hand side circular polarization for in 3D, but this one is LHCP and this one is RHCP. Same goes to the 10 gigahertz. The top part is the 4 gigahertz part, the 4 gigahertz frequency, and the lower part is the 10 gigahertz frequency. And extra, and some more, we can see the gain CP in the stack version here, and also the return loss and input impedance here. So without further ado, let me show you how to simulate this using the HFSS Antenna Toolkit. So firstly, we open the Ansys electronic desktop. The version I'm using right now is 2024 R1. So firstly, we need to create a HFSS project by clicking this. Now, we want to use the automation and the ACT extension. This is for the designing the to use the antenna design toolkit. So we're waiting for the ACT extension to load. Okay, now we launch the wizard. We click on this HFSS Antenna Toolkit. Then I'll expand this. So we can see here all the antenna type. Under bow tie, you can see there's more. This is the bow tie, is the general one, and this one more the more specific one. You can see bow tie antenna. This one bow tie antenna rounded, and this one bow tie antenna slot. So there are different versions of the bow tie antennas. But in this example, we are going to see the conical spiral and the for specifically for conical lock spiral here. So if you click on different antenna type, you can see here, down here, there's the graphic for what is the dimension. So you don't need to worry about the what do you need to put inside the dimension. You can just refer this graphic. So it will show you what are the dimension are. And we're using the conical lock spiral here. So for the low frequency, in this demonstration, I'll just use all the default value here, which are the low frequency is 4 gigahertz, high frequency is 10, outer boundary is radiation, and etc., including the dimension. So we just click finish after we put all the dimension here. And after we click finish, they'll create a all the required result for this simulation. So expand this. You can see here, they already created the 3D design for this antenna. And you can see the boundaries they already created for us. And the excitation and the ADC setup, you can see for the frequency of 4 gigahertz and 10 gigahertz. And for the result, uh, the RHCP and ACP for 4 gigahertz. The 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 first one, all these three are for 4 gigahertz. You can see the MDC here. The frequency is 4 gigahertz, and if you can see when it ends with one here, like for example the FF3D gain RHCP1, LHCP1, and the gain CP1 here. You can see it is for the 10 gigahertz. So they create two of the frequency, and they show you the gain, the return loss, and the input impedance. So our next step is we just right click this and analyze. So it'll take a minute to finally simulate all of this. And okay, let's just wait. I think less than a minute to finally simulate all of this. So we can see this, the design, the 3D design. Okay, plus 3 already. Okay, let's just wait. You can see here down here is the message manager and the progress. So these are the progress bar for all the simulation. You can just wait for the for a message that it is already simulated. So we just wait for the message. Two. Remove this. Use this. So while waiting this simulation to finish, I want to add something. By clicking on this project, you can see these are all the dimension for the antenna that we put in the design toolkit. The inner radius, the number, the offset, expansion, and code height. And if you want to change it, change the design, you don't need to go to the design toolkit and create a new one. Just click on this dimension here and just change the number, change to whatever you desire for the design. So it's very easy. And like this one, number of 10, you can just change it here. So I won't change it in this now because we still simulating the result. So just in case in your future project, if you want to change the dimension, you can just change it in this design parameter. Okay. So we're still waiting for the result. Okay, now you can see the progress is already finished. You can see in the message manager here. It says normal completion estimation on server. So now we go to all the result. I'm not sure why this result is not showing. Okay, see the HTTP here. Again, into B here in 3D. This one for 10 gigahertz. This one LHCP in 10 gigahertz. This one you can see the result for 2D game and all of this for 10 gigahertz. In RCP in 0 degree, you can see the red line. The blue line is the RCP in 590 degree. So you can see all this result of the simulation. I'm not sure why it's not showing here. Let me analyze this back. Maybe because we change. Okay, you can see here. And all this result, you can see in 3D. For the 3D result, we can show this in inside the inside the design. After this, I'll show you how. You can see the gain stack here. You can see all for all the RCP and RCP, the synchronization for all the in 4 and 10 gigahertz. The return loss, you can see the return loss here. You can also see the input impedance in the Smith chart. And to see the 3D result inside this antenna, so basically we go back to this design. We click on field overlays. We right click it. We plot field and radiation field. So for example, we want to see the gain RCP. So now we change the scale to 1:1. And for instance, if you want to check on uh, the gain RCP for 4 gigahertz, so you just click the visible and apply. You can see it around the antenna. And same goes to the LCP for 4 gigahertz. Just click apply. Same goes to RCP in for 10 gigahertz. Click apply. And also for LCP in 10 gigahertz. And you also can stack both if you want to observe this. So yeah, that's it. Right. If you want to don't want to see the the related field. So basically we unclip up and we click apply. So now we only see the design, the antenna. So that's basically it on how to design antenna using the Ansys HFSS design toolkit. Uh, if you have any question, you can ask me now, uh, or maybe I'll pass the screen to Zulaika for further instruction. Okay, Zulaika, you may take over the screen.
Okay, thank you very much, Mr. Farhan, for this informative webinar. I hope you have been enjoying the presentation so far. I already launched a poll. Please select the appropriate response and click submit. Now, it's time to address your question. Feel free to type your question in the chat features, which you will find at the right of your screen. We will do our best to answer as many questions as possible during this session. Does anyone have a question regarding this topic? If we do not have any questions, I think it's about to come to end. So, Mr. Farhan, is there anything else you wanted to cover?
Uh, if you guys want to see the recording of this webinar, you can check out our YouTube channel, Dynafom Engineering and Technology. So for all our the recording for the previous webinar for electronics, you can search there. So previously using HFSS, we've done many such as filter, the introduction, and we simulate filter. So if you want to interested in that topic, you can go to our YouTube channel. Yeah, I think that's about it.
All right. Thank you, everyone. We appreciate you being here. We also encourage you to connect with us on social media. We are happy to provide additional support. You may contact us through email or telephone. Thank you all for attending. We hope you have learned and enjoyed this presentation so far. Have a wonderful day.
All right. Thank you, everyone.